So, in my absence, I just wanted to make a little video to help you kind of get started or actually give you direction. Hopefully you have been working on pages 2 through 6, numbers 1 through 11, kind of step by step into vertex edge graphs and specifically vertex coloring. Okay, so yesterday we talked about how the vertices are the points and the edges connect the vertices. Usually if there's some kind of relationship. Yesterday, 3 of the examples that we had would be that bridge problem where different parts of the city were different vertices and the bridges were the edges connecting the different parts. So showing A and B had 2 bridges, so they had 2 edges connecting them. Same thing with B and C, and D had 3 different connections going to or from it. So the vertices represented sections of town, edges were the bridges. Another example where you might use vertex edge graphs that we will look at would be the maps on maps. And so the example I gave you is the map of the Midwest and how each state had its own vertex, and you connected the vertices with edges to represent a shared border. So for instance, Iowa shares a border with Missouri, Nebraska, South Dakota, Minnesota, Wisconsin, and Illinois. So the vertex in Iowa, drawn in Iowa, has an edge going to the vertices in each one of those states. Okay. Similarly, if Iowa, which is realistic, does not share a border with Ohio, we are not drawing an edge from the vertex representing Iowa to the vertex representing Ohio. They don't share an edge. Okay. Another example was a floor plan, and I know 5th hour did not quite get to this. Some of you might have looked at it, but here we had different galleries and we had doorways. The doorway represented a way to get from one gallery to the next, and we noticed that some of the galleries only had 2 doorways. To other galleries, some of them had 3, some of them had 4, and it's just, how can I get from one gallery to the next? So we represented each gallery as a vertex, and then each doorway was the edge between the vertices, or edges between the galleries there, those doorways. So the next thing we're going to do is something called vertex coloring, and this is where my creative side kind of comes into play, because you do get to use colors if you so desire. I grabbed my markers, and I would do this in college as well, to actually, when we're coloring or giving a name of a color to a vertex, I would actually color it. The visual is very helpful. Not all of you may think that though, and that's okay. So this is one way to really help us kind of get rid of some conflict. So problems where certain people may not work together, or if you're scheduling things, or in this case, a radio station broadcast. So if you read this, you've got 7 new radio stations, and in this visual right here, you see how they're laid out. And use this to help you decide how close they are. So as you're going through this, I do have the answer key on Schoology, so I'm not going to give a lot of the answers. This is more of a directional thing on ways to get you started, suggestions. So if you want the answers, this is not necessarily the place to look for a complete answer key. Okay. For 1, 2, and 3, really just think logically about these answers. You don't even necessarily need to know a ton about vertex edge graphs. You just need to think if there's going to have to be 2 different radio frequencies, and if you're not clear what that is, that's like if I turn my radio on to 92.3, 107.9, 96.1, other ones too, okay? So they would need different radio stations, in essence, the frequencies that you would turn to on your radio if they're within 500 miles of each other. So use that idea for 1 and 2, and even 3. It asks, why do you think? Not what's the correct answer. Why do you think? So think about it. Open up your mind to thinking like that. Come up with an idea, and we can talk about it, or you can double check what you think my answer might be and compare them, and then we can talk about it as well. Some suggestions I have, though, is that when you're trying to decide how many miles apart they are, yes, you can count horizontally, yes, you can count vertically, but when it comes to diagonals, so for instance, if I'm looking from X to Z and I want to know, are those two within the 500 miles or are they outside of 500 miles? So my suggestion is think right triangles, okay? Just like when you did slope, do the rise over run, whatever, you could have drawn it underneath. But look along that top or horizontally, that's 3 squares. So each square is 100 miles. So this would be 300 miles horizontally. Vertically, this is also 300 miles because it's 3 squares. If you, for the estimation process here, because you know you're going to take whatever the answer is and multiply it by 100, you could say that's 3 and 3. If you recall the Pythagorean theorem, that tells me, and we'll call this C temporarily, that 3 squared plus 3 squared equals C squared. Well, 3 squared is 9, and I've got 2 of them, so it's like 9 plus 9, which is 18. And to figure out what C is, I would take the square root of both sides, so I'm going to estimate that C squared, which is, or C, which is the square root of 18, is probably somewhere between 4 and 5. And you might be like, how did you get to that conclusion? Well, I know 4 squared is equal to 16. 5 squared is equal to 25. Last time I checked, this 18 falls between 16 and 25. This is probably going to be closer to 4 is what square root of 18 is. Okay? So somewhere in that range. So, seeing as it's less than 5, I'm going to estimate that there will be an edge between x and z following this 5-mile radius, or having 2 radio stations within 500 miles of each other. If I do the same thing with t and x, you would find out that those two are outside of 500 miles, so it'd be between 500 and 600 miles. And so you can estimate it that way without actually calculating the exact number. If you want to calculate the exact number using right angles, go for it. But that is a suggestion on how you can decide which vertices should be connected. Okay. On the next page, when you get past 1, 2, and 3 answering those questions, feel free to discuss with each other what you think that is. And we can talk about it when I get back. Here, yes, it can be solved with trial and error, and so that's why we're trying to think of more of a systematic approach, okay? So this is kind of your opinion, what should the vertices be, and how do you decide whether they're connected? For part B, there's really 2 ways to do this. In the end, I will tell you, I think in problem 6C, oh no, 7, I tell you exactly what I want you to do. Kind of right there, which one I think you should do. Basically, all the vertices should be the radio stations. I have that set up for you on the last page. And then it's your choice how you connect an edge. Just keep in mind you are trying to figure out which ones are connected, so that way you know which ones need different frequencies. Okay, so if they are connected, that might be more useful to know. So connect vertices if they are within 500 miles of each other. That way you know, oh, if these 2 vertices share an edge, they have to be colored differently, and that's kind of the direction we'll go here in a little bit. When I say color differently, I actually do color them, but like I said before, you can just write the color, the name of the color. I've had to do that when I haven't had colors right next to me, like markers or crayons or different colored pens. But basically, the different colors would represent different radio frequencies, okay? Because if you think of it this way, if I've got an edge and it's got 2 endpoints, you want that edge to have 2 different colored endpoints. So an edge cannot have the same color. at both ends. Okay, so the vertices connected by an edge have to be different colors, just like they have to be different frequencies in this case. So that's when we talk about the conflict. If they share it, they have to be different. So for 5, we can talk about this. This is probably one I will discuss with you on Wednesday. So compare with people around you, see what you think. Same with B and same with C. Number 6, when you look at my answer key and you look, I would look at 4C above, because 4C is the same thing as what 6A is talking about. So if yours matches my 4C, then it should be a yes here. If you did anything different than 4C above, this should be a no. Okay? And then you would have to draw something that looked like 4C. Turning the page, I went too far. 6B, if yours matched 4C and then you put yes for 6A, this one's going to be different. Okay, basically the difference is that anything that was connected before. So if you let your edges represent, or you drew your edges where your vertices or your radio stations were within that 500 miles, you are not going to draw those in anymore, those edges. Instead, you are now connecting vertices that are greater, so more than 500 miles apart. So for instance, in the last one, you probably did not, if you matched my 4C, you probably did not match or connect T and X with an edge, those two vertices. However, here, you would connect them. And as I talked to you about in 4C, well, talked to you about using the Pythagorean theorem to help you decide whether two vertices were 500 miles or less or greater, figuring that one out, we use the example of vertices X and Z. And so we figured out that X and Z were within 500 miles. So we connected them in 4C, and which is the same as 6A. In this example, vertex X and Z, those two vertices, would not be connected because they are less than, and only edges are drawn in this example, 6B, if vertices are more than 500 miles apart. Look at my notes, look at that answer key, and if you're not quite sure, and go with that. For the next one, I want your opinion on those. You can get my opinion on the answer key. But a couple quick things, because this video is going to quit on me here in a moment. So we're going to use the graph that I did in 4C. So look at that one. That's where the edges are 500 miles or less. So this is looking at the conflict of when do I have to have different frequencies. Okay. So you can also draw a little bit differently, so they don't have to be in that same way. But I want you to describe that, do the best you can, think about why they're the same, what does it mean for there to be vertices, and then what do the edges actually represent. So it doesn't really matter the layout. That's basically what I'm asking. Okay? When it gets to coloring, a few things. So if you're on page 5, so two stations have different frequencies. That means two vertices have different colors. Okay, so if as I'm coloring, and if you look at my notes, if two vertices have different colors, that means they have to have different frequencies. Okay, please fill out this table in my notes. I would think about them first, but I will fill out one of them for you. Use the fewest number of frequencies. That means you're going to use the fewest number of colors. Oops. So then I just have you try it and have you compare it with other people. You are taking the graph from 4C and actually putting color